Assalamualaikum and a very good day class. So we meet again in this week 3 video. We still under topic first order ordinary differential equation, but for today we'll cover here the solution of differential equation. And also we'll go later for the general and particular solution, and the last part is initial value problem and boundary value problem. The solution of differential equation is referred to the unknown function y and its independent variable x on the interval I, in which this function yx satisfies the differential equation identically for all x in I. So to make sure you understand this definition, let's now we go to the example of this y. So the first example here, let's say we have yx equal to c1 sine 3x plus c2 cos 3x. We want to check now for arbitrary constants c1 and c2, is it this equation yx is a solution for y double prime plus 9y equal to 0. This is a step how to solve it. So now class, to make sure you understand, let's we do it one by one. We have here y double prime plus 9y equal to 0, and we want to check whether this y equal to c1 sine 3x plus c2 cos 3x. Is it this equation is a solution to this differential equation? So how to check? You see in this differential equation, you have a term y double prime and you also have a term y. Means that you need to substitute y double prime and y in this differential equation. And then if this right hand side equal to 0, means that it's fulfill this differential equation, so that this y is a solution for this differential equation. So let's start one by one here. Let's go one by one here. So let's go one by one here. First, we differentiate this y. We have here y prime equal to 3c1 cos 3x. You need to have knowledge how to differentiate this function. And then here, when we differentiate cos 3x, we'll got here negative 3 sine 3x. So we'll have negative 3 c2 sine 3x. And then we need next to differentiate this y prime. So we have y double prime, and then when we got this one, we can substitute in this equation. So y double prime equal to negative 9. Why we got here 9? Because 3 times 3. Negative because you differentiate cos x, you will got negative sine x. So negative 9 c1 sine 3x minus 9c2 cos 3x. And the next step, number 3, we need to substitute y double prime and y in this differential equation. So we'll have here y double prime equal to this equation. So we'll have negative 9c1 sine 3x minus 9c2 cos 3x, and then plus 9. Our y is this equation. So we substitute here 9y. You substitute with this part. We'll have here c1 sine 3x plus c2 cos 3x. So we'll have this one equal to negative 9 c1 sine 3x, and here we have plus 9 c1 sine 3x, so plus 9 c1 sine 3x and minus 9 c2 cos 3x, and then plus here 9 c2 cos 3x, and then you can see this one will become 0, and here you can cancel out, become 0, means that it is equal to 0. When this one equal to 0, means that you have shown this y double prime plus 9y equal to 0. So we can conclude here y equal to c1 sine 3x plus c2 cos 3x is a solution for y double prime plus 9y equal to 0. Now class, we go to the next example. You need to determine whether y equal to x squared minus 3 is a solution of y prime to the power of 3 plus y equal to 0. How to show this? You have to find here y prime, and then you need to substitute in this equation, and then you substitute y here. If you can show the right hand side equal to 0, means that this y equal to x squared minus 3 is a solution for this differential equation. So the first step here, we compute here y prime. Simple function, so you can directly find the derivative of this function. It is equal to 2x. And then we know that our y equal to x squared minus 3. So we need to substitute y prime and y in this differential equation. So for step number 2, we have here y prime, okay, y prime to the power of 3. So 2x to the power of 3 plus y. And y is given by x squared minus 3. When we solve this one, we got this part is 8x to the power of 3 plus x squared minus 3, which is it is not equal to 0, means that we can conclude here y equal to x squared minus 3 is not a solution for y prime to the power of 3 plus y equal to 0. Next class, we go to this example. Is yx equal to 10 a solution of y double prime plus 2y prime plus y equal to 10? Here we have y equal to 10 means that when we differentiate this one, we got it is 0. We differentiate again twice, we got here equal to 0. For step number 2, we substitute y double prime, and y in this equation. So we will have here 0 plus 2 times 0 plus 10, which is when you solve this one, you got equal to 10. So this one equal to this answer, means that we can conclude here y equal to 10 is a solution for y double prime plus 2y prime plus y equal to 10. Now we go to types of the solution. In ODE, there are two types of the solution. The first one we call it as general, and the second one is particular. What does it mean by general solution of ODE? It's referred to a solution of differential equation which contains one or more arbitrary constants. Means that in this case, when the solution is said general, it has a constant. Contains a number of arbitrary constants equal to the order of the. If the order of ODE is 2, means that number of constants also 2. It is the set of all solutions, means that this arbitrary constant can be any value. It cannot always be expressed by a single formula. Okay, because actually, for example, if we have yx equal to 7x plus c, this c can be any value. You can substitute with 1, 2, 3, and so on. So it cannot always expressed by a single formula. And for this one, if you have yx equal to c1 exponential 2x plus c2 exponential negative 3x, we can say that c1 and c2 are constant for this case. And there are two constants here, means that the order of the differential equation that has this solution is. And then we go to the particular solution. When additional information is given so that constant may be calculated. If you have additional information, so you can calculate the constant. In that case, the solution is called particular solution. For example, if this c, we can compute it and we got actually 4 here. So this y equal to 7x plus 4, we call it as particular solution. And for the second one here, if c1, you can calculate, which is you got negative 1. And c2, you got equal to 6. And then the solution of this yx, we can call it as a particular solution.